you for taking the time to come along today. I think it'll be a useful and informative session. I am the chair of the Water Environment Society of Engineers Ireland. My name's Sheila, and I'm hosting the session today with Pierre Yimbog, who's also staff with Engineers Ireland, and he works on the community engagement piece. So the aim for today was really to give an insight into the life of two engineers who are working in the water sector. And it's really about how they got to where they are today, what their career path was like, and what they enjoy about their roles at the moment. And we're also offering some information about graduate programs and other ways of linking in with Engineers Ireland and also Uisce Éireann. But the stories today, we have, first of all, a talk by Liam Metcalf, who is working in Uisce Éireann at the moment. And after Liam, we have Olivia O'Brien, who is based with Nicholas O'Dwyer, and she's giving us the angle of working as a consultant in that sector with more international experience. So I think we'll have two nice views of the kinds of pathways that you would be open to you if you're considering a career in the water sector. So without further ado, I'm going to hand over to Liam. Liam will speak for about 15 or 20 minutes. Then Olivia will speak for 15 or 20 minutes. Pierre has a few things to say then, and we'll finish up then with a question and answer session. And just to let you know that this session is currently being recorded. So I'll hand over to you then, Liam. Thanks very much.
Thanks, Sheila. I'm just going to share my presentation here. Yeah, my name's Liam Metcalf. I'm an assistant project manager with Uisce Éireann Irish Water. Do bear with me, as Uisce Éireann is a new name, so if I mix between the two, I do apologize in advance. So just to give you a bit of background about myself, I'm from Cape Town, South Africa. I have a BSc in chemical engineering from the University of Cape Town. And in 2020, I was able to complete a postgrad diploma in professional engineering with Engineers Ireland in conjunction with TU Dublin. But I'll get onto that a little bit later. So I moved to Ireland in 2017, and my first job from graduating was as a process engineer with Jacobs, the consultancy. And I was on the Jacobs team that was out at Intel in Leixlip. Really interesting project, first experience of working in like a multidisciplinary team, working with mechanical, civil, and just really a good introduction into being an engineer in the industry, and especially on such a large construction site like Leixlip, Intel in Leixlip. So I knew that I wanted to move on from sort of the consultancy side, but mainly more I wanted to get into the water sector. And so what I did was I interviewed to get onto the Irish Water Uisce Éireann graduate program. So this is a 2-year program where you do 3 8-month rotations. The first rotation that I did was in the environmental regulation department. So here we were looking at things like plant discharge licenses, monitoring the different types of treatment plants that are all over the country, and there are many. You know, just getting a brief understanding of how we manage the overall country's wastewater and water plants. And also what was interesting was interacting with the Environmental Protection Agency. Yeah, that can be a good experience just to see what that kind of back and forth is like. The second rotation I was on was in the asset planning department, and this is where we looked at more how do we fund new treatment plants coming up for Irish Water Uisce Éireann to install. Also looking at things like planned maintenance, where you need to generate maintenance plans for different treatment plants that have a specific lifespan. And then one thing that was interesting that I was a part of was helping develop asset management standards within the business. And that really helped me see an overall view of the whole of Irish Water, Uisce Éireann. I told you I was going to flip between the two. And really understanding how the different departments interact, and whereabouts I might like to set myself up. The third rotation, which was my favorite rotation, was in operations in the process optimization team. This really opened up my eyes to what I really wanted to do within the water sector. I said there that I was always wanting to be in the water sector, but I wasn't sure where I wanted to be specifically. And I worked with the wastewater treatment process optimization specialist, and he really opened my eyes up to wastewater treatment. I started realizing the similarities between wastewater treatment and what I studied in terms of chemical engineering, because there's a lot of biological treatment processes that happen within wastewater. So I was really inspired and knew that I now wanted to be on the wastewater side of the business. So yeah, in that department, we looked at optimizing processes, assessing critical plants, and then interacting with the local operators. So that was the 2-year program. On the program as well, we had a number of different types of training days. The first thing you get is a mentor. Really lucky to get a person who you can just introduce you to the business, show you the ropes a little bit. Have any questions, you can ask them. We also were able to do a few site visits. Went to Ballymore Eustace and Malahide. And then we did like technical training days. So we'd get, a water treatment process day and a wastewater treatment process day, again, right up my street in terms of what I wanted to find out more about. And again, key in that decision making for deciding to be in wastewater. We also did Microsoft Office training, so Excel Advanced, Dashboard, PowerPoint, again, really important. I know there's a lot of Excel in university, but this was really that kind of next level where you can do a lot of like reporting and develop those kind of skills that are actually beneficial to your department. We also got taught a lot of soft skills, and I think like when you start out in your career, it's really important to develop that side of it. It's one thing to have a degree, it's another thing to use that degree and then go into the workplace. And I think the soft skills like communication, assertiveness, presentation skills, those are all things that are really important, especially at the start. You want to learn a lot, you want to get involved with your team. And the more you're able to communicate well and talk to people, I think that's a big benefit for when you start your career. And then at the end, you do a group project. They assign you a team of graduates, and you enter into a department, and they basically give you something that's real life, something that they need assistance with, and you do a group project. So that's the end of the grad program. I then was able to successfully get into the major projects department, which is a project management department within Uisce Éireann, as an associate project engineer. The first project I was on was the regional biosolids storage facility, or the RBSF, and this building is to store treated biosolids that come out of the Ringsend treatment plant. The things that I was doing there was helping develop the tender documents, managing the tender assessment process, and doing things like tender assessment scorecards and creating and drafting award and regret letters. And then at the end, we appointed a contractor. However, 2020 being the year that it was, we were seen as a project that wasn't critical to the business at the time. And so the project actually got shelved for a little while. Up until now, actually. And so yeah, like that was just kind of the year of 2020 that it was. But fortunately, then I got moved on to the Ringsend upgrade project, and I'll tell you a little bit about that now. In 2020 as well, my manager, we were in a projects department, and he said that I needed to get some more project management training. So what I was looking for was something that's related to project management training. But what I found was the Engineers Island Diploma. Now, at the time, it was called the Diploma in Professional Engineering. Now it's called the Diploma in Engineering Leadership and Management. It's a 12-month part-time course. So initially in 2020, it was in person, and then it moved to online, and now they kind of do a hybrid of the two. It's for engineers with 3 to 6 years experience. And the way that the course works is that you learn the modules, but then you also write out these learning contracts, which I think are really good, because you can learn as much as you want from the module, but are you actually implementing it in your job? And these learning contracts, you actually have to sit down with your line manager from work and say, I'm learning these modules, and this is how I'm going to apply it within my job. So I thought that was a really good way of making sure that it was actually effective and really helped you. And because I was in a project management department, it was perfect for me. You also do assignments, and then at the end you do a final group project. And it's at an NFQ level 9, which is at the master's equivalent, but it's not the same amount of ECTS credits. So it's just a postgrad diploma. So just to give you a short view of it. So the first one there, engineering project management, like I said, doing project management was important for me, but then you get all of these other things as well: management, leadership, negotiation, and influencing skills, again, into that soft skills kind of element. Contracts, claims, dispute resolution, that was really interesting because, you know, being in project management, that's something that you always need to be aware of. And in finance and risk management, I was the risk champion on my project, so that was also key for me to learn more about. On the side there, you can see the competencies. So that's actually taken out of the Engineers Island chartership application. So it's kind of that introduction into what the chartership competencies are, and how those modules can address them. But I'll get to the chartership a bit at the end. Like I said, 2020 was a bit of a crazy year for all of us. And like I said, the RBSF was shelved for a bit, and I was fortunately enough to move on to the Ringsend upgrade project. So I'm just going to take you guys through a little bit about Ringsend, because I think it's really interesting. And in terms of being in the water sector, this is one of the most, in my opinion, one of the most interesting projects in the country. So there's Ringsend. It accounts for 40% of Ireland's wastewater. It was originally designed in 2003 for 1.64 million PE's population equivalent, so the equivalent amount of wastewater of the population that you're treating. But that was with no nutrient removal requirement. Then a nutrient removal requirement came in, which is like reducing the amount of nitrogen in the effluent and phosphorus in the effluent. And actually, under those standards, the plant was actually had a capacity of 1 million PE. So it's currently overloaded with 1.9 million PE's worth of wastewater. So that's what our job is now at the Ringsend Upgrade Project. And our project objective is to deliver on a phased basis the capacity to treat wastewater for a population equivalent of 2.4 million, while achieving those treatment standards that the Urban Wastewater Treatment Directive dictates. We have an interim objective at the moment, so we want to achieve compliance for 2.1 million PE by the end of this year, and we're on track to do so. So how are we going to do this? Well, we're implementing a new technology called Narada, which is an aerobic granular sludge technology in the plant. And it's developed by a Dutch consultancy, Royal Haskin and DHV. And they're our consultants on the project, and we're implementing it through these upgrade contracts and multiple upgrade contracts on site. Some are in construction, some are complete, and some are still in procurement at the moment. So there's Ringsend from a bird's eye view. So like I said, we're implementing the Narada process in these tanks. So the first thing we had to do was we had to prove that the technology worked. So we converted one of the cells into a Narada tank. Once we saw that the results were positive, that was then the basis for building a secondary treatment capacity called the CUC on top of the Ringsend plant. And that's basically 6 Narada tanks, 3 at the top and 3 at the bottom. I get my laser pointer here. Okay. Yeah, so 6 tanks, 3 at the top, 3 at the bottom. And then once that was fully operational, we were then able to drain down 8 of the tanks over here. And so now that the wastewater is going partially into here, but also into the CUC, we're now retrofitting these 8 blocks into full Narada tanks. If you can see on the side here, there's like an upper deck and a lower deck. So if you can imagine, these are 12 tanks over here. There's another 12 underneath those. And those 12 underneath, as well as these 4, are in what's known as hybrid narrator. So we're not fully draining them down and replacing the pipework internally. We're just using the sludge that's produced in the narrator sludge, which is actually quite heavy and good for settleability. We're putting that into the hybrid system. And that's kind of helping the settleability of the granules as of the sludge as well, and the separation of clean water and sludge. So that's on the water line, that we like to call it. Because we're also doing a lot of processing a lot more wastewater, we're processing a lot more sludge. And on the left-hand side here, we're upgrading and expanding the sludge treatment process on this side. So I don't know if you can see here, but there's 4 circles over here. Those are actually anaerobic digesters. So what we do is we put the sludge through multiple drying processes and thermal hydrolysis. And then they go into these digesters, and we actually produce biogas. You can see the gas balloon just over there. And that biogas is put into what we call combined heat and power engines. And they actually process 50%, approximately 50% of the plant's power capacity. So there's a good example there of a good circular economy. We're using the sludge that we have to convert into electricity and power the plant. Another thing we're doing is we've just built a new phosphorus recovery facility. So there's phosphorus out the wastewater that comes out of the centrifuges and dryers. And this can sometimes clog up pipes and things like that. So we're actually removing that with this phosphorus recovery facility. And what we do is we actually are precipitating out the phosphorus into a compound called struvite. And that's actually quite valuable as a fertilizer and can be sold off. So yeah, that's the Ringsend upgrade project. Really interesting, really happy to be a part of the team. And yeah, we're looking forward to getting compliance for 2.1 million PE at the end of this year. So what's next for me? So I would like to become a chartered engineer with Engineers Ireland. It's aimed at engineers with at least 5 years experience. It's a registered professional title that's internationally recognized. So if you went to work in another country, you could become, those qualifications will transfer over. So what does it involve? You have to do a career summary report. This is just detailing your whole career. And I showed you guys the competencies there from the diploma. That's where you have to address those 5 engineering competencies and what you did throughout your career to address them. You also have to do continuous professional development, or CPD. When you start working, that will be probably at the forefront of most of your development plans. So continue to do CPD, engage with your CPD, and you need to have done 35 hours at a minimum every year for at least 2 years before you apply for your chartership. Then you also have to do 2 essays. One is from a list, basically, that's predefined by Engineers Ireland, and another one's on a topic of your choice. And then you also have to have 2 supporters from your either from your work or from your career history, and they have to be chartered engineers as well, because they know what's required. And they basically sign off and say that yes, he has achieved, he has done all this work, he or she has done all this work, and they can progress their application. So once all of that is complete and you finish your application, you have to do an interview with 3 chartered engineers, and it's basically for an hour. And then they're from your stream, maybe it's chemical or water or project management, and they'll be interviewing you and making sure that you are at the standard for a chartered engineer. So I'm progressing that this year. My application is due for June. Hopefully I'll get through and do the interview within August, September. So yeah, that's me. Any questions you have at the end, I'm happy to answer them. I'll pass over to Olivia now.
Good afternoon, everyone. My name is Olivia O'Brien, and I will be presenting on my career path in the water sector. So just a bit of background from me. So I graduated with a bachelor's and master's degree in civil engineering from the University of Stellenbosch, and I've been working in the consultant industry for about 9 years. And most of my experience on water projects is related to pipeline hydraulics, network modeling, and the design of bulk water infrastructure. I'm currently living and working in Ireland for 3.5 years as a project engineer with Nicholas O'Dwyer, working mostly on water resilience projects in the UK. So the format of my career path will be split into 3 phases: my early career, my career progression, and my current role. So in my early career, I joined Oricon in Cape Town as a graduate engineer. And for my first 2 years, that comprised mostly of preliminary design of bulk water pipelines. So I performed tasks on the following projects: the design of approximately 20 kilometers of steel pipelines for the implementation of a municipal bulk water master plan. And then I worked on a project that was the proposed new water supply scheme to replace a semi-desert town's most saline water sources. And I performed a hydraulic model of the service water network within a wastewater treatment works in Namibia. And I was involved in the pipeline routes and sizing of 3 treated effluent distribution networks for the city of Cape Town. Treated effluent is treated water that falls below drinking water standards for use such as irrigation. So in these projects, I assisted senior engineers with tasks. I familiarized myself with software packages such as Civil 3D and hydraulic modeling software. I sized pipes and pump station capacities while understanding the pressure and velocity constraints. And then I was also learning how to prepare a bill of quantities and understanding the specifications related to that bill of quantities. So this image displays one of the treated effluent distribution networks I worked on, and it shows the types of end users in different colors. So these could be schools, industries, commercial buildings, etc. And then I calculated the demands based on the types of end users. And then I used the hydraulic model to size the pipelines and pump station capacities, considering both the pressure and velocity constraints. So the 3rd and 4th years of my early career comprised detailed design of pipe networks and in-depth hydraulic modeling. So I worked on a hydraulic model of the existing and future extensions of a semi-purified network across Windhoek in Namibia. So semi-purified water is similar to treated effluent. I created a hydraulic model comprising multiple water sources and pump stations that were ready within the existing system. And then I was responsible for presenting any required upgrades to the current system, in addition to future solutions to pressure problems, given the extension of the network. Another project I worked on was the design and hydraulic modeling of 7 treated effluent distribution networks supplied from various wastewater treatment plants across the city of Cape Town. So this was a comprehensive project, quite integral to my career development, because I did extensive network modeling, given that the size of the networks were up to 91 kilometers. I attended site visits along the pipeline route to amend the route accordingly. I performed the detailed design in Civil 3D of pipe long sections for 2 of the treated effluent networks. So yeah, this is just the image on the left shows the existing network and users of the semi-purified network in Windhoek. So you can see the different colors, again, that's just related to the type of user. And then on the right side, this is the additional users that needed to be added to the network. So again, the demands were calculated based on the type of end user. And then I used the hydraulic model to size the pipelines and identify any required upgrades to the network, given that there'd be future extensions. So this is an image of a wastewater treatment plant supplying treated effluent via a dedicated main. So as I said previously, the water is treated to a specific standard, but still falls below drinking water standards. So this is cost effective for non-drinking water uses such as irrigation or industrial use. And this is one of the treated effluent networks within the city of Cape Town. So I was responsible for verifying demands, pipeline sizing, and required pump capacity to achieve the pressure and velocity requirements. And then once the network model was complete, I performed the detailed design of all the pipelines within the network. So this concludes the section on my early career. And then I joined IX Engineers as a civil engineer to work on projects related to the City of Cape Town's water crisis. So the Cape Town water crisis in South Africa was a period of severe water shortage. The water crisis peaked during mid-2017 to mid-2018 when the water levels dropped below 30% of the total dam capacity. At the most extreme, residents were restricted to a maximum of 50 liters per person per day. So just to give you an idea of scale, the City of Cape Town provides water to a population of 4.9 million people. So in 2017, plans for Day Zero were implemented by the city, which is a reference for the day when the water level of the major dams would fall below 13.5%. And Day Zero would be the day when municipal water supplies would be largely switched off, and it was envisioned that residents would have to queue for their daily ration of water. So then the city planned to have a greater portion of Cape Town's water supplies met from alternative sources by commencing augmented water supply schemes, which includes groundwater abstraction and desalination. So I worked on one of these schemes, which involved the development of groundwater in the Cape Flats aquifer as an additional water source to supplement the bulk water supply to the city. So the geohydrologists identified new boreholes across the Cape Flats, which required associated infrastructure to obtain 83 megaliters of additional water supply. I was involved in the bulk water supply infrastructure to link these 8 borehole clusters across the Cape Flats area, and each having their own set of conveyance and supply infrastructure. So this is what the well field looked like. So groundwater was abstracted from various borehole well fields and then pumped through a network of conveyance pipelines to a nearby site for treatment and then storage prior to injection back into the existing bulk water networks. So I was responsible for the design, development of the infrastructure, which, as I said, comprised the conveyance and injection pipelines, the storage tanks, construction documentation, contract admin, and sometimes part-time supervision. So this is an image showing the conveyance and injection pipelines. And in the background, you can see the storage tank site. This is during construction. So we'd have a storage tank for the raw water and then a storage tank for the potable water. And this is just an image showing the production borehole chamber that was constructed. Another one of the city's water resilience schemes included a large-scale permanent desalination plant. So this is very new technology in South Africa, which made the project quite interesting. So it involved the feasibility investigation of various desalination plant installations across the city as an additional water source to augment the bulk water supply. So I was involved in bulk water hydraulic modeling of 4 potential desalination plant sites based on a 150 megaliters per day supply. So I needed to investigate the viability of each site based on the distribution of the desalinated water into the existing bulk water network. This concludes the section on my career progression. So although I was working on interesting projects in South Africa, there was an opportunity to move to Ireland and expand my skill set. And I joined Nicholas Adwyer as a project engineer. I transferred my qualifications and became a member of Engineers Ireland. So I've worked on 3 Irish projects. The first one was the feasibility of the East Meath groundwater augmentation scheme. That was to evaluate the potential of an additional 25 megaliters a day of groundwater for the water supply zones. I assisted with the feasibility report of multiple schemes, compiled route selection reports, and prepared the costings for each scheme. Then I also worked on the River Poddle flood alleviation scheme, which proposes flood protection, storage, and prevention measures along a 6-kilometer stretch of the Poddle River in Dublin. The next project was a flood risk management scheme within the Cashin estuary. So for both of the flood-related projects, I was mostly involved in the contract documentation. Then I've been working on some international projects, one of which is the provision of new infrastructure for wastewater collection, treatment and disposal needs of the Addis Ababa Eastern Wastewater Catchment in Ethiopia. So for this project, I compiled the feasibility reports, performed flow calculations, pipe sizing of the trunk mains, as well as the cost estimates for the new pipelines. So the image, excuse me, the image on the left shows the existing sewer network. And this was the image on the right is the proposed future extension of the network that we were designing. So this, the future scenario aimed to connect a population of 2.1 million people to the sewer network by 2045. And then I worked on another international project. It was the expansion of the existing water treatment plant in Lilongwe, Malawi. I performed the design review of the new 50 megaliters per day water treatment works. And also, I was also involved in the detailed design report with input from process and mechanical engineers. So this is the top left image is a 3D image from a drone survey of the existing Lilongwe treatment work site, with the new site to be located adjacent to the existing site. So we create design drawings using 3D software. As shown in this image, this is a rendered image of the pre-sedimentation tanks, and also another image showing what the proposed intake works would look like from the river. So my current role involves focusing solely on projects in the UK. So two projects I've worked on was to provide a second water supply source in both the Trimpley and Chester areas. So the Trimpley project entailed an options assessment of pipeline routes to provide supply resilience via a 10-kilometer bidirectional pipeline. And this would enable transfer of water supply in both directions to either of the water treatment works. So the selected pipeline route is shown on the right. And we had to look at the most direct route, avoiding all planning and ecological constraints. So the Chester project also comprised an options assessment of pipeline routes to provide supply resilience via a large diameter main. So we are currently progressing the outline design of the pipeline and also how we would connect to the existing water treatment works. Another interesting project that I've been working on is the Rugby Rail Yard project. And this involved resolving issues around the age and condition of a section of a steel trunk main located under a congested section of railway infrastructure. So this is the existing condition of the trunk main. And I needed to perform an options assessment to either replace or rehabilitate the existing 600 mil diameter pipeline, which was located under 12 active rail tracks. Another project that I'm working on includes a pump station, which aims to resolve issues around low pressures within specific areas located in Derby. And we're currently performing the outline design of the pump station as well as the connection to the existing network. So this is just an example of the pump station design using 3D software, and we include these images in the drawings we provide to the client. So that is just kind of a summary of my career path in the water sector. So you can see that it includes progressing from assisting senior project engineers with different tasks to performing the designs, contract admin reports, and submitting deliverables myself. So working at Nicholas Adwai has been really good for my career trajectory, and I thought I'd highlight some of the interesting projects our team is currently working on. So we're working on the river puddle flood alleviation scheme that I mentioned earlier. We're also designing a 50 megaliter day tank in Saudi Arabia. So the tank is actually covered in sand here because the client didn't want the tank to be visible. And then we've also worked on the Cork Lower Harbour main drainage scheme and the Bartree water supply scheme. So career development at Nicholas Dwyer includes regular check-ins, reviews with your manager, your current role and future growth objectives. There's 5 days per year allocated to your CPD. You can get involved in a mentorship program. And there's also a designated career path to help you progress your career. So I'll just take you through the career path. So this is the career path used at Nicholas Dwyer. So to use me as an example, I'm currently a project engineer, but would like to progress to a senior project engineer in the near future. So I can do this by managing financial aspects of projects and also obtaining my chartership with Engineers Island. And that's all from me. Thanks very much for your time.
So thanks to the wonderful Liam and Olivia for giving a great background and insight to their own career paths in the water sector. And definitely obviously encouraged by their intentions to obviously further their own career and their engagement with Engineers Ireland on that side of things. So as Sheila mentioned, so my name is Pierre Bug. I work for Engineers Ireland and as a community engagement executive, mainly supporting students, graduates, apprentices and technicians and global engineers in terms of their professional engagement with Engineers Ireland. In this short presentation I'll give you, I'll just obviously focus on the pathway from being a student member and obviously in terms of the graduate membership aspect of it, but also broadly in terms of the benefits of membership of Engineers Ireland. So getting into it, so obviously Engineers Ireland, that's where we're based. It's in Clyde Road in Dublin. So if you haven't been in the area itself, you're always more than welcome to visit. Our office and facilities are open now and accessible for members to attend and use it. So I definitely encourage you to pay a visit to us. So we're established since 1835. We're one of the oldest professional bodies in Ireland, and we covered the whole island of Ireland, so not just the Republic of Ireland, but also engage with members and have region within Northern Ireland for those to become a member and participate. We're multidisciplinaries, so like the speakers, they've gone through, they have multiple disciplines and where they're working at the moment. We cover from, water, chemical, civil, biomedical, so all areas of engineering. So we're not solely one professional body for one discipline itself. We've over 25,000 members across the membership base, and obviously we encourage all the members through different activities to engage with them and with each other as much as possible, because they'll benefit the most from that. We're the sole body for awarding professional titles, and as Liam mentioned earlier, around the Chartered Engineer title, it is only through Engineers Ireland that you can attain and maintain that professional title itself. We like to style ourselves as, and I like to say, the professional home for engineers. So whether you're a student, you're a graduate, a professional engineer in any organization, or an international engineer coming to Ireland, we hope that you see Engineers Ireland as your professional home to support you whatever stage you are in your journey. So in terms of benefits of membership, there's a number of them that you can avail. As I mentioned, networking and the events and building up your CPD continuous professional development. Some of the speakers I mentioned in terms of that growth and opportunity to develop yourself. Access to exclusive reports and articles such as Engineers Journal and Salary Survey. Obviously, as a member, you'll be able to put that on your profile, whether it be LinkedIn or CV, as you demonstrate that for potential employers and across the network. Again, skills and discounted courses, and opportunities again to really develop your different areas of skills, both soft skills and technical skills, and the opportunity to achieve a professional title. So we do have 4 professional titles: engineering technician, associate engineer, chartered engineer, and you can become a fellow of the Institute of Engineers Ireland. And there's pathways and routes to those. In many cases, I won't go into detail on those itself because that's a presentation itself, but there are loads of resources there, webinar recordings, and obviously we're here as staff of Engineers Ireland to support you to achieve that professional title. both with your membership of Engineers Ireland and attaining a professional title. It gives you great international mobility and recognition. So if you did choose to work in some of our partner countries, such as Canada, South Africa, of course, across the UK and many countries, you can transfer and have your professional title recognized there. In addition, if you've undertaken an accredited engineering degree through Engineers Ireland, or again in the country that has agreed to different international agreements, again you can have your qualification experience recognized that way. So if you're not already a member, I'll just run through briefly in terms of the opportunities for you to become a member of Engineers Ireland. So all our ways to become a member is all online now. So we're going with the times of online applications, and it's pretty straightforward. So whether you are signing up as a full member or a student, that can all be done online. The fee, so if you are undertaking a course, so undergraduate full-time course or postgraduate master's engineering course in Ireland or the UK, there's free membership and for the duration of your studies. While if you are signed up as already graduated and you're working as an engineer, the membership is €208. We do also have other options in terms of if you're on reduced hours, or if you're a postgraduate student or anything like that, we do offer other reduced fees. Obviously, if you're starting as applying for student membership, which is free, we don't need your engineering qualification as you are still undertaking your program. But if you are applying as a full member, we do need to see a verified copy of your qualification just to assess that. And there's many ways so you can have that verified by another member of Engineers Ireland, Garda or police, whether within Ireland or if you're applying from abroad. We have a system through Digitry, and also through some universities, you can also have them send us a link to verify your qualification. That all goes through our membership qualification board, which meets once a month, and they'll assess whether from a student application to a full member, what grade of membership you are, and obviously the path to a professional title that you would be able to undertake. And obviously from there, you can avail of all the benefits of membership. Obviously the key thing and part of my role is obviously in terms of engaging students is that obviously once they graduate, they can transfer their membership from student to becoming a full member of Engineers Ireland and be able to apply the post-nominal MIEI, so the member of the Institute of Engineers Ireland, like most members do, and avail of our discounted graduate membership. So the first year of graduation is free and it's discounted thereafter, so you don't have to pay the full €208. But I know many of those that do go into either a graduate program or work for an engineering company, their employer would pay for their membership fee as a way of obviously supporting them and investing in their professional development. But we also ensure that they also get that discounted and continue to avail of the benefits. Obviously, since this is a recorded webinar and it's been mentioned in Brown the importance of CPD, just a reminder that you can log this webinar itself as one of your CPD. As mentioned, all members, excluding students, have to do 35 hours a year, and there's multiple ways that you can avail of those 35 hours. It doesn't have to be, it can be a mixture of structured reading, webinars, get involved in Engineers Ireland activities, or doing courses within Engineers Ireland or outside of Engineers Ireland. So again, our website explains all the ways that you can do that. So as you can see there, you can obviously do that through your profile at My CPD. But also let you know, obviously, in my interest area, definitely if you're not already signed up to the Water Environment Society, you can do that through my interest area as part of the sectors, and obviously get involved in the other divisions, regions, and societies that we have. And obviously it all personalizes your profile for you, so you don't miss out on anything important that you want to get involved in. So that's just a quick run through in terms of Engineers Ireland and in terms of membership and the benefits. Of course, if there's any questions at all about whether you're a student or graduate or professional looking to learn more about Engineers Ireland, about professional titles or anything at all like that, do feel free to get in touch and obviously answer any questions that you do have after in this Q&A section. So thank you very much, Sheila.